Assalamualaikum dear student. So genetic complex nature of coat color in dogs. So this is another classical example of deviation from the Mendal laws. You can see here. So there are one E locus, K locus, A locus, B locus, D, and S locus. You can see six locus which are going to affect the color pattern in the dogs. So it's not two, rather six, and their interaction that is going to determine the color in the dogs. So story looks to be a bit complicated. And here you see the eumelanin blocking block pigment, and in that case we get the E locus is there, and we get the black. The second is the uh, pheomelanin red pigment. Sorry, we have black pigment and red. So these are basically base colors, and their effects are determined by the other blockers given over here. You can see if there is no other interactions, and we will get these two type of phenotypes. And when the interactions are there, we will get more different type of phenotypes. You can see this chart. A bit complicated stuff. Now, what we can conclude from the previous few lectures, if the normal Mendelian ratio, you can see in here seed shape and example of the endosperm color in the peas. So there is no interaction if we are getting 9:3:3:1 ratio. Okay, so if there is a deviation and we get 9:3:4 ratio, that is the recessive epistasis, and we will get 12:3:1, that is the dominant epistasis. Color in scratch example is given. And if it is a 9:7 ratio, then it's duplicate recessive, albinism in snails. And if it is 9:6:1, duplicate interaction. Now, if it is a 15:1 ratio, then it is duplicate dominant epistasis. And the last one, 13:3, uh, and that is the dominant and recessive epistasis. Both of these epistases are working well. So these are based on the intercross between two heterozygotes individuals. Now another concept, whether the two genes they are located on different locus or on the same locus, and in case of mutation, how we are going to work it out. So suppose there is M1 and M2 are two separate recessive mutations that both result in the same uncoordinated behavior. So M1 and M2 alone, if they are there in both of the copies, it would be uncoordinated. Similarly, M2, M2, both of the copies uncoordinated. Now, if one of them is divided, it would be WT, either with the M1 or M2. You can see here. Okay, the second one. Now, if both of these mutations are present in trans configuration and uncoordinated behavior is observed, like here, M1, M2, and you still find this is heterozygosity, then these mutations do not complement each other and are alleles of the same genes. Now, if they are not like that, the other way, the second M1 plus M1 plus M2. So alternate form is plus. Either the case is the M1 or M2. So they are looking seem they seem to be two different genes and different locations. So thanks for listening this lecture. Now in this lecture we basically covered the concept of the just summarized how interaction works, and then how we can determine whether the mutation is because of the same gene or because of the different genes located on different